Okay, the review. Number 1. This is a picture of it almost completed. If the central angle AOB is 120, the arc is 120, which means the inscribed angle is 60. It's actually asking you for this angle, but they're all 60 degrees. Number 2. This is a simple two chords making an angle inside the circle. So it is the two arcs added up divided by 2, and that equals 140 divided by 2, which is 70. Number 3, the angle's outside the circle. So you subtract the arcs, divide by 2, and that equals the angle. This time the variable isn't here, the variable is here. Same equation, but the algebra is a little bit different. So it's 120 minus x equals 80. 120 minus what equals 80? It would be 40. Number 4, if the two chords are congruent, then that means the two arcs are congruent. So if one of them is 150, so is the other one. That makes 300 degrees, which means that this one is 60 to make 360. If that's 60, then that angle is 30 degrees. Number 5, we talked about this in each class. That's the diameter. So half the circle is made up of a 2-to-1 ratio, 2x, 1x. 2x plus 1x equals 180. Solve that and you get x equals 60, which means 2x equals 120. The measure of angle ACB is this angle right here. If this is 60, then that is 30. Number 6, it told you that it gave you, let's see, that information right there. What you want is this arc and this arc. This isn't really involved, except you need it to find this one. So if an entire circle is 360, and you've used 120 and 170, then this arc must be 70. Now you don't need this one. It's 120 minus 70 divided by 2, which is 25 degrees. And your next one was here on 13. It told you that angle CAB was 48 right here. Because it's a diameter in an inscribed triangle, we know that that's 90, which leaves 42 for here. If that's 42, then the arc that it opens up, AB, has to be 84. Remember, I'm going fast, but you can always pause the video and watch it as much as you want. So this is a basic two-chord distance formula, or distance, not arcs and angles, but distance. So it's 6 times x equals 9 times 4. That part is 6. ED, right there. Number 15, it wants you to find PA. The tangent squared equals the outside part times the whole thing. Not 6, not 12, but the whole thing is 8. X squared equals 16. That's a nice 4. Number 16. So I've labeled what they gave us. PC, the whole thing is 16. The inside part is 12, and the tangent they want you to find is PA. So what is the outside part then? Wouldn't that have to be 4? Because 4 and 12 make 16. So the tangent squared equals the outside part times the whole thing. So x squared equals 64. X is 8. Outside times whole. 17. Let's label what it has given us here. If AF equals FB and they're both 5, and DC is 7, this is the tricky part here. They're telling you that 2 are equal and they're both 5. So let's work our way around. If this is 5, then that's 5. If this is 5, then that's 5. If that's 7, then that's 7. So the perimeter is 7 and 7 5 and 5, 5 and 5. The perimeter is 34. Number 18. DE is 6. EB is 4. AE is 3. What's EC? Similar question to what we had before. 3x equals 24. This times this equals this times this. X equals 8. And number 19. This is going to be Pythagorean theorem, but let me show you how we got there. It tells us that BA is 15. It tells us that OB is 17. And it tells us that we have a radius meeting a tangent. Well, radius and tangent always meet at 90. So it wants us to find a radius. Well, this is a radius right here, so that can be our x. Well, what we have there is a right triangle. So we can use Pythagorean theorem. X squared plus the other leg, 15 squared, equals the hypotenuse squared. Take away 225 from both sides. And the answer would be 8. The key there is that a radius and a tangent meet at 90, and you use Pythagorean theorem. Number 20. This is all it gives you, that AE is 9 and EB is 4. But then it says that AB is perpendicular to the chord. So if that's 90 right there, remember, then that means these two are equal. If they're equal, we can call them both x, and then use our chord formula. One part of the chord times the other part equals one part of the chord times the other part. Number 21. Outside part times whole thing equals outside part times whole thing. So 16x equals 96. So x would be 6. Outside times whole equals outside times whole. 22. If AO is 10, AO is 10, so that only goes to that part there. And BE is 4. Find the length of CE. This one's a little bit of a curveball because you're missing this little section here. It's not a radius, it's like part of the radius. But if the radius is 10, anywhere you draw it, it's 10, right? The radius is 10. That means that all of that would be 10. And if that part's 4, then that little part must be 6 to make 10. So that makes this entire part 16. So now I can go x squared equals 4 times 16. A little bit of a tricky curveball there. Number 23, these two add up to 180, and these two add up to 180. So we have that is all we really need because it wants us to find angle A, which is in this corner. Supplementary, add up to 180. And number 24, we have kind of a weird looking sector here. It's all of this. That's one big sector. So it's like 3/4 of a pizza is one big super slice. And the radius is 12. So we have area of the sector, pi r squared times. Now because this is 90, we know that this is 270, the remaining part of the circle. So 270 out of 360, which is really just 3/4. So you can type that into your calculator, which is 144 pi. And if you want to shorten it like this, it would be times 3/4, which is that. Which on your calculator comes out to be that one. Okay, number 25. The area of a sector of the circle with an arc measure of 30. And radius of 6 is what? We're talking area of a sector again. So pi r squared times 30 over 360. And here I have 36 pi, right, 6 squared. I can tell that a lot of them are in terms of pi. And 30 over 360 is the same thing as 3 over 36, which is the same thing as 1 over 12. So really I have 36 pi over 12. 36 divided by 12 is 3, so 3 pi. Calculator can give you the same answer. Number 26, no picture, so I'm going to draw a circle. And it tells me that the arc was 3 pi long. If it comes from a circle that has a radius of 12, what's the measure of the angle? So arc length was pi d times the angle over 360. So I have pi times the diameter, not the radius, equals something over 360. And that equals 3 pi. So this is like one of those cases where it gives you the answer and you have to find the angle. So I have, canceling my pi's on both sides, balancing the equation. I have 24x left over 360 equals just 3. Multiply both sides by 360, and that leaves me with 24x equals 1080 divided by 24. I think that gives us 45. And the last one. So this is another super slice of pizza, except we're talking about a giant sector. All of that Pac-Man area in there. So we're talking area. Area is pi r squared times the angle over 360. Simplifying that, 15 squared is 225 pi. You could type it right into your calculator from here if you wanted to, and it comes out to be about 588 and change, which rounds up to 589. I went through that pretty quick in 12 minutes. It should take you a lot longer than 12 minutes to do this, but you fast forward, rewind, replay, and remember the test is very similar to, it's shorter than this, it's very similar to the folded stuff that we did on the 2 sheets of paper. Good luck.